Anecdotal reports claim that iPhones can last for 5.7 minutes in the microwave before catching fire. A local statistics instructor, that's me, I purchased 11 iPhones and I found a mean time until phone catches fire to be 5.5 minutes with a standard deviation of 1.3 minutes. Assume the variable follows a normal distribution. Test for statistical significance at the 1% significance level. So for each of these 11 phones, it took a different amount of time for them to catch fire in the microwave. If I recall correctly, one of them took actually 8 minutes. But the summary overall was 5.5 minutes. And then from that sample of 11 phones, I got a standard deviation of 1.3 minutes. Now, we have to assume that our variable, the time it takes to catch fire, follows a normal distribution for each one of those individual phones. That way, the central limit theorem is going to work for our sampling distribution of the sample mean. So we'll set up the hypothesis test in a moment, but what I want you to do is consider, is this a good model of reality? And what I mean by is this a good model of reality is a model of reality where we have the sampling distribution centered at 5.7, is that a good idea of reality or a bad idea of reality? What we're trying to do in hypothesis testing is reject that 5.7 is a good idea of reality. Basically, what we have is the hoe door and we have the other door. If the null hypothesis is true, how crazy would a sample mean of 5.5 minutes be? Consider that. Would that be crazy? If the true mean is really 5.7 minutes, then, by the central limit theorem, this would have to be at the center of the sampling distribution of the statistic. So all we're doing in this problem is testing if the normal model is a good idea for how long it takes for these phones to catch fire. Is it a good idea? The evidence as to whether or not it's a good idea or bad idea is 5.5 minutes. Is 5.5 minutes so far away from 5.7 that we can't just say that it's just the randomness and luck of it. That's why we calculate the z-score. All right, so we're looking for statistical significance here. So we'll set up a hypothesis test about the parameter mu representing the true mean time it takes for these, the real mean time it takes for these phones to catch on fire in the microwave. Is it 5.7 minutes or is it just something different? Let's calculate our test statistic. That is negative 0.51. And our rejection region is pretty critical. The evidence has to be pretty convincing. We can reject the null hypothesis here if our test statistic is more extreme than negative 3.169 or more extreme than 3.169. We'll only reject the null hypothesis if our test statistic is unusual enough. Unusual enough in terms of the t-distribution and the idea of variability given a small sample size and only using the sample standard deviation instead of the population standard deviation. We're not going to reject the null hypothesis here. Our evidence is not even remotely convincing.